All right, guys. Mr. Jenkins here with your video for lesson 4.2, which is about graphing quadratic equations that are written in standard form. So in 4.1, you'll recall that we worked a lot with how to graph quadratics that were written in what we called vertex form. That's that unsimplified looking formula where it's kind of easy to pick out things like the vertex, H and K and all that. Whereas today we're going to be going away from that and looking at quadratic equations that are written in a more traditional, what we call standard form. Okay, so that's the big idea. On that note, let's go ahead and get right to it. Example 1 says, use a graphing calculator to graph y equals negative 1x squared plus 2x plus 1. So we'll go ahead and just type that right in to our graphing calculator. So negative x squared plus 2x plus 1. And I'm just going to kind of get a visual here to see if I can make out where the vertex is. And I have my windows a little bit screwed up, so bear with me. Let me fix that real quick. Make everything kind of 10 by 10. And we'll look back at it again. Okay, so now it's more obvious. It looks like my vertex is at maybe 1, 2. And we can verify that just to be sure by looking at a table of values. So remember we said it looked like 1, 2. And when we look at that part of our table, we can tell that it is our vertex because we see that symmetry on both sides of that point. 0 goes to 1, 2 goes to 1. Negative 1 goes to 2, 3 goes to negative 2. Okay, so we see that symmetry. We know that the point, again, 1, 2 is our vertex. So basically, we're just going to use this table of values to graph our parabola. So I'm just pretty much plotting points right out of the table. All right, so we said 1 goes to 2. That's my vertex. 0 goes to 1. 2 goes to 1. And then we say negative 1 goes to negative 2. And so 3 is going to go to negative 2. So those are my points. I'll just draw my curve there. I like to draw my axis of symmetry just to have that visual. All right, and remember your axis of symmetry goes right through the vertex. So then they want us to fill out this table based on kind of what we see there. So again, our vertex was at 2, 1. Our axis of symmetry, sorry, I wrote that backwards, 1, 2. Our axis of symmetry is at x equals 1, or is x equals 1. Domain is pretty automatic on these. You can bet it's going to just be all real numbers because we can just plug in anything for x. The range is where you have to think a little bit. I like to think about this last part first. Our output value of the vertex, this 2 here, is a maximum value, and I know that because when I look at my parabola and think about where my y values are, they're always at or below 2. It never goes above 2, so 2 is my maximum value, and therefore my y values are always less than or equal to 2. Okay, so we did all that in the first lesson, but that's just a little review. Okay. All right, so then we get into some more algebraic kind of stuff. And this is important because on some of these questions, it's not so obvious where your vertex is, okay? So let's go ahead and look at some algebraic ways that we could, the most important thing from this example is going to be how to find that axis of symmetry, how to find the middle of your parabola. I'm not gonna type this one in. I'll just go. You'll just take my word for it that we get a weird kind of vertex. So The example says find the vertex, the axis of symmetry, the minimum or maximum value, and the domain and range. All right, so you actually have to do it a little bit out of order where we want to find this part first. This would be kind of our step one. So step one, we're finding our axis of symmetry. That's the middle of the parabola using the formula. This is an important one, so note that on your notes. Negative b over 2a. So we would just say x equals negative. And then as far as your a's, b's, and c's go, a is the coefficient of x squared, b is the coefficient of x, and c is the constant. So when I sub in b, that would be 2 over 2 times, and then a is negative 4. When I simplify this expression, I think about the fact that I have 2 negatives would make this positive. And then basically I just have 2 over 2 times 4, which would reduce down to 1 over 4. So we can say that x equals 1 over 4, or I'm just going to change that to a decimal, 0.25. All right. Now that we know that, we can use that to find our vertex. And we'll do this as our step 2 of this problem. All right, so we have half of our vertex, or half of the numbers that make up our vertex. So now we have our input value of the vertex. Now we can find the output value of the vertex. So we know basically at this point it's at 0.25 comma something. And we're going to kind of find the output value on this step. Okay, so we're just going to plug in 0.25 as the input value of our function. So negative 4 times 0.25 squared plus 2 times 0.25 minus 3 gives us whatever it gives us. So I'm going to use my calculator for that just to save a little bit of time. So I'm going to hit second and mode to quit. And that was negative 4. Those parentheses can be important. If you ever have a negative, I'm just going to use them anyways. The negative 4 times 0.25 squared plus 2 times 0.25 minus 3 gives me negative 2.75. So now I know my vertex overall, kind of running out of room there, is at 0.25 comma negative 2.75. So that's my vertex. And again, we wouldn't just be able to use our graphing calculator and find that. That would not be obvious. Okay. So then step 3, name the maximum or minimum value. So first of all, is it a maximum or minimum? For that, I would think about the fact that A is negative. All right, so if A is negative, it opens down the parabola, so that makes our value a maximum. And then the value is the output value of the vertex, right? So that guy right there, that negative 2.75. So we say our max value, this is as high an output as this function's ever going to produce. All right, is y equals negative 2.75. All right, and that helps us with our domain and range. That's the last thing. So domain is easy. That's kind of a gimme, all real numbers. And my range would be y values that are something than negative 2.75. So either less than or equal to or greater than or equal to. And if that's my maximum value, then all other y values would be less than or equal to that. Okay, so a lot going on in that example, but that kind of shows you how you can, you know, it's not obvious on these problems where your vertex is. You know, that's like it is in vertex form. So that is how you can pull it out. All right, so just to save time, because example 2 is pretty easy to pull out points from your table, let's go ahead and skip ahead to this last one, which is pretty tricky. So we'll finish the video on that, okay? So one thing I would always suggest that you try to do on these is type in your function rule. In this case, it would be y equals 3x squared plus 2x minus 3. We can kind of see if I did that our vertex is not easy to find. So I'm going to go ahead and start by finding my axis of symmetry, right? I'm going to do that first. So it's x equals negative b over 2 times a. So that's negative 2 over 2 times 3. All right, so overall it's going to be negative because there's only one negative. And then that's going to simplify to 1 over 3, which I want to leave as a fraction. Okay, so this is not going to be easy right off the bat. So I know now that my axis of symmetry is at x equals negative 1/3. And I know that my vertex is going to be at negative 1/3, comma something. Okay, and we'll figure out what that is, right? On my graph, let me zoom in a little bit here. Show you kind of what that would look like on our graph. So negative 1/3 is just to the left of 0. So I'm just obviously trying my best there. All right, so it's going to be somewhere along that line. X equals negative 1/3. Okay, so to get its output value, we're going to do the same thing that we just did last time. We're going to sub in negative 1/3 here and here, which would be like this. 3 times negative 1 over 3 squared plus 2 times negative 1 over 3 and minus 3. And we get negative 3.33, but we want the fraction version of that, right? So remember, to get that, you can go to math and fraction and just hit enter. So that's equal to negative 10/3. All right, so that's my vertex, negative 1/3, comma, negative 10/3. All right, so we'll just do our best to get that in the right spot. So negative 10/3, that's negative 3.3-ish. So about right there. And then from there, it's going to be pretty tricky, right? So usually we get easier numbers. So if this were like negative 1, then we'd plug in, say, like 0 there and negative 2 there, okay? But it's not negative 1, it's negative 1/3. So instead, what we'll do is maybe plug in 0/3, which is 0, and 2/3, right? Which seems like it might be difficult, but it's actually, there is a shortcut, okay? There's another thing that I kind of skipped over earlier, and that is the fact that you can look at this at the beginning and kind of easily find your y-intercept. Okay, it's just like on a y equals mx plus b equation, your constant is equivalent to your y-intercept. So y-intercept is always in the form 0, comma c. So I can look at this and know that my y-intercept is 0, comma negative 3. So just based on that formula, I know this goes to negative 3, and since we're evenly spaced from the vertex, without plugging it in, I know negative 2/3 would also go to negative 3. So I'm going to zoom it back in, I think, if I can. Nope, we're all the way zoomed in, and just try to do as good as I can there. So negative 2/3 goes to 3, that'd be about there. 0 goes to 3 would be about there. And really, we're not going to fiddle with getting a bunch of other points just because that's all we would need for our Math XL problem. And this is a difficult example, but I was just really wanted to go over how to find the vertex and stuff like that on a tricky one. So tricky example there. The one above is a little bit easier if you want to work an easier example. Okay, and then we will finish with this last problem, which is kind of a multiple choice deal. It just says, which is the graph of negative 3x squared minus 4x plus 6? So we could easily type that into our graphing calculator and just see which one best matches. Instead, though, we're going to practice some algebraic shortcuts or algebraic aspects of this. Okay, we're going to focus on that. All right, so the easiest thing to look at right at the beginning is that a is negative. Okay, it doesn't matter that it's negative 3. A is negative. That tells me that our parabola is going to be one that opens down. Okay, so that tells me right off the bat that it wouldn't be that one in the middle. Okay, from there, another easy thing to look at is that the y-intercept would be 0, 6. That might help us answer the question or differentiate between the last two. But on this problem, it ends up not. So we can see that this one actually goes through 0, 6. I believe this one goes through 0, 6, and we've already eliminated it. And that one goes through 0, 6, right? So they all end in plus 6. Lastly, we can do the axis of symmetry, right? So if we take a look at which choices are left, we can differentiate, right? The one on the right is split right down the middle, so its axis of symmetry would be x equals 0, whereas the one on the left is off center a little bit. Okay, so let's see what our axis of symmetry is, practicing that formula one more time. So again, it's x equals negative b, so negative negative 4 over 2 times a, which is negative 3. So simplifying, I have 1, 2, 3 negative, so overall it's going to be negative. Then I have 4 over 6, which we can reduce to 2 over 3. So while it's not an easy axis of symmetry, that does tell us its center is not x equals 0, it's x equals negative something, which eliminates this choice. Its axis of symmetry would be x equals 0. This one could be x equals negative 2/3. So that makes that choice our winner. Okay, and again, if this were a test problem, the easiest way to do that would have just been to type it in. Negative 3x squared minus 4x plus 6. Look at the graph, and then it's pretty obviously that first choice, but I wanted to show that algebra one more time in the video. So that's it. Hopefully this helps, and you guys have a good one.